In this video, we're going to find the slope of a line algebraically and graphically, and then be able to classify it by type. So before we find the slope of a line, we need to define what the slope of a line actually is. And the slope of a line is first and foremost a ratio. And the slope of a line is the ratio of the vertical change to the horizontal change between 2 points on a linear graph. So for example here, the slope of the line that we see here, let's pick 2 points. So say I picked this point right here to be point A, and this point right here to be point B. So what I'm going to find here is my slope is the vertical change over the horizontal change. So I'm just going to create a ratio of this. So my vertical change between point A and point B is I need to go up 1, 2, 3, 4. So notice here I vertically went up a positive 4. So when I'm finding the slope of a line and saying vertical change to horizontal change, my vertical change is how I've changed vertically. Did I go up or down? That determines positive for up, negative for down, and then how many units. So my vertical change here is a positive 4. My horizontal change is then how I moved horizontally, which means left and right. If you forget which is which, I always think of, okay, when we have a sunset, it's in the horizon. So the left and right one, that is your horizon. So that's how I remember horizon, horizontal. But here, our horizontal change is how we move left and right. So here, we are moving to the right horizontally 2 spaces. And if I'm moving to the right, I'm moving in the more positive direction because I'm moving forward towards more positive x values. So this is a change of positive 2. So here when I write my slope is that ratio. It's the positive 4 over 2, which you can then simplify to 2 over 1. But my slope is that vertical change, how did I move vertically, over how did I move horizontally. That is where slope actually comes from. Now, depending on how you've been exposed to slope in the past, there's a number of ways you could have seen slope. So we talked about slope as the vertical change over the horizontal change. This can also be worded as your change in y. So how did you change with your y value in your points? And how did you change in your x value in your points? So change in y is another way of saying vertical change. Change in x is another way of saying horizontal change. And the most popular way that you think about slope is rise over run. And here, rise means you're going up or down. So rise is a fancy way of saying vertical change, and run is a way of saying horizontal change. So any of these, if you've heard them before, they're all talking about the exact same thing. Now, this piece down here is called the slope equation. And you'll notice that it has a variable m. M is a common variable to represent slope. So if you see m, you should be thinking m is a common way of representing slope. Now, this equation right here is what we can use if we have 2 points and we need to find the slope algebraically between 2 points. So that's what we're going to work on next. So what we're going to do first is we're going to pick 2 points on our graph, and I'm going to show you how you can utilize the slope equation to find the slope between those 2 points. So I'm just going to pick 2 points. I'm going to pick this point right here. That's going to be point A. And that point is at the point x is -3, y is 0. And then from here, I'm going to pick this second point up here. I'm going to call that point B. And that's the point x is 3, y is 4. So we're going to utilize the slope equation here, and we're going to actually calculate our slope algebraically using the slope equation. So remember, slope, the letter for slope is m, so we'll write m is equal to, and then we need to talk about what this y2, y1, x2, x1 actually represent. So when we're finding the slope of a line, we need to denote one point as 0.1 and one point as 0.2. So what I'm going to do here is I'm going to denote point A as 0.1 and point B as 0.2. And then from here, the y2, y1, x2, x1 represent specific parts of that point. So in point 1, we're going to label the x-coordinate of point 1, x1, and the y-coordinate of point 1, y1. So that's what that stands for, x of point 1, y of point 1. And then we're going to go to point 2, and we're going to label it x of point 2 and y of point 2. So when you see those in this slope equation over here, that's what they really represent. This is y of point 2 minus y of point 1. X of point 2 minus x of point 1. So now we're going to actually substitute those values in. So let's start with y2, and if I look over at the points that I've labeled, I see that y2 is 4. So I'm going to write 4 minus y1, if I look at y of point 1, is 0. Then I look at x2, and I see that x2 is 3. So I have 3 minus x1 I see is a negative 3, so I'm going to put in a negative 3. And then what I need to do from here is I need to simplify the numerator and simplify the denominator. So I can see that 4 minus 0 is simply 4. And then I can also see that I have in the denominator, I have a keep, change, change. So that really becomes 3 plus 3. So my denominator becomes 6. And then from here, I note that both of these are divisible by 2. So this fraction would simplify to be 2/3. So when we see this big slope equation up here, that's all we do. We have 2 points. We need to have 2 points to find the slope of a line. We label x of point 1, y of point 1, x of point 2, y of point 2, and that will essentially, if we plug those points into the slope equation, help us find our slope, which is our rise over run, change in y over change in x, or vertical change over horizontal change. So on the last slide, we used point A and point B, and we use those 2 points to calculate our slope. But the most common question I get from students is, does it matter what points we pick? And since we're unsure, what we're going to do is we're going to pick a different combination of points and see if we do in fact get the same slope. So what I'm going to do here is I'm going to label point C here in the middle, and this is the point x is 0, y is 2. So what we're going to do on this slide is we're going to use a different combination of points to find the slope and see if we do in fact get the same value. So what I'm going to do here is I'm going to use C as point 1, and I'm going to use A as point 2. So what I'm going to do to calculate my slope is I'm going to go in and I'm going to change C to point 1 and label it x1, y1. And change A to point 2 and label this x2, y2. So here my slope is going to be calculated as m. We're going to then in our numerator have y2, which I can see is 0. So 0 minus y1, which is 2, divided by x2, which is negative 3, minus x1, which is 0. So if I simplify these, what I find is I have a negative 2 over a negative 3. Since they're both negatives, it's a negative divided by a negative, so I know my answer is a positive 2/3. And then if we check, what we notice is even though we picked different points and used them in a different order, we get the same slope. So what that's telling me here is my answer to this question is, does it matter which points we pick? No. Regardless of the points that we pick, we will always get the exact same simplified slope as long as you are utilizing the slope equation correctly. So what we're going to do on this slide is we're going to calculate the slope of each of these 4 lines algebraically using this slope equation up here. So to start, we're going to start with number 1 over here in the upper left-hand corner. I'm going to start by labeling my points as x1, y1, x2, y2. So I'm just going to pick this as x1, y1, so that's point 1, x2, and y2, that is point 2. So my slope m is equal to y2, which is 1, minus y1, which is 5, divided by x2, which is 3, minus x1, which is a negative 3. So if I simplify this, 1 minus 5 is a negative 4. Then I use keep, change in my denominator, and I get 3 plus 3 is 6. Then if I simplify this fraction, I find that my slope of this line is a negative 2/3. Then if I move on to the second example, what I see here is I have 2 points, so I'm going to label them x1, y1, and x2, y2. And then I go to calculate my slope, and I take y2, which is negative 4, minus y1, which is 0, all divided by x2, which is negative 2, minus x1, which is 0. So now I've substituted in my values. My numerator becomes negative 4 over negative 2. I notice that I have a negative over a negative, which is a positive. And then I know that both of these are divisible by 2, so I can simplify this to be a positive 2 over 1, or 2. Then if I look down at example 3. So in example 3, what I see is I have 2 points. I'm going to label them x1, y1, x2, y2. So then from here I'm going to go and I'm going to calculate my slope using that slope equation. So it's y2, which is 4, minus y1, which is 4, divided by x2, which is 3, minus x1, which is a negative 1. So my numerator becomes 0. My denominator, we use keep, change to get 4. And then I know that 0 divided by 4 is actually 0. Then from here, in my last example, I have x1, y1, x2, y2. And then I'm going to calculate my slope accordingly. So I take y2, which is negative 1, minus y1, which is 4, x2, which is negative 4, minus x1, which is also a negative 4. So notice I have another negative. Then I'm going to simplify this so the top becomes negative 5, divided by my denominator, which if I use keep, change, negative 4 plus 4 is 0. And what I should know at this point is that we can't have 0 in the denominator. 0 in the numerator is okay. That's going to result in 0. But 0 in the denominator, if you do negative 5 divided by 0 on your calculator, you're actually going to get an error. So on the previous slide, we calculated the slopes of the following 4 graphs, and we actually found the 4 different types of slope. There are actually 4 types of slope, and they're pretty obvious once you see the 4 types. So this first one, because we have a negative number as our slope, has a negative type of slope. So that negative number tells you that you have a negative slope. Now, the other way that we can see we have a negative slope is we read the graph like we read a book. We start on the left side and we move to the right. And what we're noticing is that as we move from left to right, our graph is going down, like a hill. It's going downhill. So here, because this graph is going down over time, it has a negative slope. So there are 2 ways you can see it. Either visually, as we go from left to right, the graph is going down, or our slope is resulting in a negative number. Now if we move to example 2, what we notice on this one is we have a positive number. So hopefully you're already starting to conclude that we have a positive slope. Now, similar to a negative slope, the way to tell here is we read this graph from left to right. And what we notice here is that as we go from left to right, we are going up. So you ultimately have 2 ways that you can tell that you have a positive slope. Either as you move from left to right, you're going up, or you have a positive number as your slope. Then from here, if we look at the next one, the next type of slope is called a zero slope. And hopefully that's pretty obvious. And the reasoning is simply because we have a slope that results in the number 0. Now the easiest way to tell is that this is a flat ground. You're walking on a flat ground, there's no hill, it has 0 elevation, it doesn't change in any way, shape, or form. So here, because it's flat and it's horizontal, we have a slope that is 0. So those are 3 types so far. We have negative, positive, and 0. And this last one here where we have a straight vertical line, this is called an undefined slope. And the easiest way to tell that we have an undefined slope is because we have an error as we're calculating our slope because we can't have this 0 in our denominator. So the way that I tell that it's undefined versus 0 is a 0 slope, I could walk on that ground easily. It's a flat slope, I can walk on it. But an undefined slope, I couldn't walk up this line because it's not possible to turn my body fully parallel to the ground and walk straight up into the air. I would fall. So because of that, we can't define that slope because it's not something that we could actually measure and walk on. So those are our 4 types of slope. You should be able to identify a negative slope, a positive slope, a 0 slope, and an undefined slope. So here we're simply going to take the 2 points that they've given us, calculate the slope, and then classify it by type. Remember, our 4 types are the positive slope, negative slope, 0, and undefined. And then the other thing to remember is our slope equation is m equals y2 minus y1 over x2 minus x1. So let's start by calculating the slope of that first set of points. I'm going to label them x1, y1, x2, y2, and then I'm going to go to my equation. So my equation is y2, which is negative 1, minus y1, which is 5, all divided by x2, which is 6, minus x1, which is 3. So here, if I simplify this further, I end up with negative 6 over a positive 3. I know that both of those are divisible by 3. So this simplifies to be a negative 2 over 1, or simply equal to a negative 2. So m, you could write negative 2 over 1 or negative 2. Either is fine. Then from here we need to classify it by type. And because this is a negative number, I know that this is a negative type of slope. Then from here, if I move on to number 2, again I start off the same way, x1, y1, x2, y2. So then from here we're going to take our slope equation and substitute in the values. So y2 is 4 minus y1, which is 4, divided by x2, which is 4, minus x1, which is negative 2. So we end up with 0 over, keep, change, we have 6. 0 in the numerator is okay. 0 divided by 6 is simply 0. So because I have this slope of 0 over 6, which then equals 0, I know that I have a type 0 slope. And finally, last 2 problems. So we're going to start off, we have x1, y1, x2, y2. Remember, our slope equation is y2 minus y1 over x2 minus x1. So here we substitute in the values, so we have y2 minus y1 divided by x2 minus x1. So here we have 1 minus 5, which is negative 4, over 3 minus 3, which is 0. I know that 0 in the denominator is a problem. That's something that doesn't work, and it's going to, as a result in an error. So my slope, you can write negative 4 over 0, but you should also know that the 0 in the denominator causes that to result in an error. Then from here, what we need to do is we need to classify it by type. Because we have this error occurring, our type is undefined. And finally, the last problem, we have x1, y1, x2, y2. We calculate our slope, so we have y2, which is 6, minus y1, which is 3, divided by x2, which is 4, minus x1, which is negative 2. 6 minus 3 is 3. And then the denominator, we use keep, change to get 6. So we end up simplifying that by dividing both the numerator and the denominator by 3 to get 1/2. So my slope here is a positive 1/2. Because our slope is a positive number, our type is a positive type slope.